Hello and welcome to another video. Today we're going to be continuing on with the Typescript line 75 and we're going to be doing merge two sorted lists. So this problem is pretty straightforward. You're given two sorted lists like this, 2, 4, and essentially you want to merge them into one list. And the way you want to do this is you want to make sure that your final list is sorted as well. So this is a pretty straightforward problem. I'm going to briefly describe it and then we're going to go into the solution. So what we're going to do here is we are going to have two pointers to each of the lists, and then we will have a dummy node as always. So we'll have our dummy node, which we'll call this D, and this is going to be where we are going to be adding our nodes to. And essentially all we're going to be doing is we're just going to be comparing our two nodes every time, and we're going to take the smaller node and we're going to add it to over here, and then we're just going to move these pointers up until we are out of bounds in both. So what that'll look like is, let's say for this first one, we'll just take this top one. You could take either one because they're the same. So we'll just move this here. So essentially we're saying like the next pointer of this, whatever this is going to be this, right? And then we move this up to here. So now this is pointing here. And now this node is this node. So we need to break this section. So we're going to break this. And then we are going to compare again. And now one is smaller. So we're going to do one over here. So this was over here. We're going to say the next of this is this node. Now we are going to move this up and we are going to break this section over here. And then 2 is smaller. So we're going to say, okay, the next of this node is 2. So next is 2. We move this node up again. And then we break this section over here. And then we have a 3, so the next of that is going to be 3. And yeah, this keeps moving up to be the very last node in the list. So the next of that is 3. And then this node gets moved up over here, and then we break this section of the list. So now we are on 4, and we can pick either one. So let's just pick the top 4. And now we are over here. This now goes out of bounds. This current pointer is out of bounds. So we are done with this list, and now we have a pointer here still. So now the next of this is going to be this 4, and now this is going to go out of bounds. So essentially, it's pretty straightforward. We can just write down our steps really quick. Make a dummy node and 3 cur nodes, 1 for each list and 1 for output. At every step, take the smallest node and add to the output and move that node cur up. And then finally, when we are out of bounds on both of the original lists, return dummy.next, right? So once we do all this, the node we need to return is going to be this node over here. So we're going to return dummy.next. This is our dummy node. And that will essentially give us a sorted list. Pretty straightforward problem. And also if you run into the case where like one list is a bunch of nodes, like let's say this list is a bunch of nodes, and the second list is like no nodes because they don't necessarily have to be the same length. And let's say we're like out of bounds here and we are here on the top list. We can just say if we're out of bounds on one of the lists, let's just connect our output node to wherever we are, and that we can connect it to this whole thing, right? We don't need to like keep looping through because essentially we just need to connect it to the rest. And so that's pretty much it. So let's try to code it up now. And so let's actually look at the VS Code here first. So once again, we'll go over the list node class briefly in TypeScript because it's a little bit confusing. So the list node has a value, which is a number, and a next, which is a list node or a null. And then in the constructor, it has a value and a next. Value is a number, next is a list node or a null. And question mark means it's an optional parameter. So it can be passed in, but it doesn't have to be. And then you set your value equals to, if it's undefined, you make it 0, because if you don't pass this in, like if you make list node, if you just say new list node here, then value will be undefined and next will be undefined. So if value is undefined, we'll just make it 0, otherwise set it equal to whatever was passed in. And then next, same thing. If it wasn't passed in, let's just make it null, otherwise we make the next that's passed in. And this function merged list is going to take a list node, which is going to be list1, which is going to be a list node, or null, and list 2, which is list node or null, and it's going to also take a, it's going to return a list node. And let's actually look at the constraints here really quick, because I forgot to do that. So let's see. So number of nodes in both lists are in the range 0 to 50. So they can be like null nodes. Okay, so let's start off with making a dummy node. So we can just say const dummy equals new list node. And we are just going to make it just like this. We don't need to give it a type because we're already saying it's list node type. So if we look like even if we let it be something, so you could see dummy is declared, but its value is never read. But then if you say like dummy equals 5, you can't do that because the number 5 is not assignable to list node. So we're going to make dummy, it's going to be const because it's not going to change. Okay, and then we need to make a few more things, right? So we need to make 3 current pointers, so let's do that. So let's just say let cur1 equals list. Actually, I don't think we need 3 cur pointers because I think we can just use the list 1 and list 2 as the cur pointers. I think that would be fine. Let's try that. And let's also we'll just make 1 cur pointer for the output then. So let cur equals dummy. Okay. Now we're going to say, we're just going to use these 2 list nodes as the cur pointers for the 2 nodes. So we can say while list 1 or list 2, and now here, so what are the conditions we can have? So first we're going to check if one of them is out of bounds. So let's just say if list 1 is out of bounds. So if not list 1, then what do we need to do? Well, then we just need to add list 2 to the cur and just break the loop. So we can just say cur.next equals list 2, and then we can just break out of this loop. Then we can also say if not list 2, same thing, cur.next equals list 1. We break out of the loop because we're basically done. Now we can check for our actual conditions. So we can say in here, so we could say if list1.val is less than list2.val, then we're going to say cur.next equals list1, list1 equals list1.next, and then I think we need to move up the current pointer, so we're going to say cur equals cur.next, and then finally cur.next equals null. There we go. So essentially what we did there is in our picture here, like if we're trying to add this node and let's say our cur pointer's here, we're saying cur next is this, then we move up this current node, and then we also need to move up our cur node to be this node, and then finally we break this little thing here. Okay, so I think that's correct. Now we need an else case, which is basically the same thing. So this is just else. And then we just need to swap list 1s with list 2s. So list 2, list 2, list 2, and there we go. And then finally, so this should, like after this is over, we should have traversed through both lists. So now we just need to return cur.next, and so we can't really test this, and I mean we could if we wanted to, we could make a bunch of list nodes, but it's kind of annoying. So let's just bring this up into LeetCode and let's test it there. But yeah, essentially that's all we need. Let's find that, and let's just paste it in and see what happens. Hopefully we didn't get an error. It looks like we did. Okay, so list 1. Okay, so we did get an error. Okay, so for some reason so let's double check our code. So if not list 1, let's just also always print cur, I think, just to make it easier for us. So let's do that. Okay, so it's a list node, but then after that it's just an array. So we're doing something wrong here, obviously. Okay, well let's double check. So if actually let's see what there is one more time, and let's look at this. So this is okay. So it's 1 1 2 3 4. So it's a list node at first, but then it's for some reason it's these nodes. It's not like a list node anymore. So that's clearly wrong. So let's see why that is. Okay. If not list one, cur.next. Okay. Cur.next. Okay. If list one.val, cur.next, cur equals cur.next, cur.next equals null. Oh yeah, this needs to be dummy.next, but I don't think that should matter. Well, let's see. Maybe it does. Maybe it's just the way it prints. Yeah, okay, that didn't matter. So let's get rid of this console log. Yeah, so we want to return dummy.next because that's the first node. Okay, so that did work, and you can see it's reasonably efficient. So let's think of the time and space here. So for the time, it is O of... Let's take a look. Yeah, I definitely think once we get into these harder linked list problems in TypeScript, TypeScript's already kind of buggy. Like, at least I haven't been using it enough. It's easy to make mistakes compared to Python. And linked list problems, as they get tougher, are also notoriously difficult to like debug and make sure you did everything right. So we'll see how that goes. But okay, so let's say list 1 is length m and list 2 is length n. So we're traversing them both. So that's going to be m plus n. And for the space, we only made a dummy node and everything else is in place. So that's O of 1. And yeah, I think that's going to be it for this problem. Hopefully you liked it, and I'll see you in the next TypeScript video. And if you did like it, please like the problem and subscribe to the channel. And I'll see you in the next one. Thanks for watching.